These are examples for alkenes. Okay, so our first example, we have 3 carbons. So we know it's going to start with prop. And because our double bond goes from the first carbon to the second carbon, that would mean it's 1. And then we know we have prop. And then it ends in -ene because we're doing alkenes. So it would be 1, and then my blue is going, -ene. Our next example, we have 1, 2, 3, 4 carbons, and our double bond goes from the second carbon to the third carbon. So it would be 2, because it starts on the second carbon, but for 4, and then -ene because of alkenes. So we have 2, and then but, that's not working, and -ene. For our third example, we have to draw 2 hexene. So the hexene tells us that we have 6 carbons and somewhere there's a double bond. The 2 tells us that the double bond goes from the second carbon to the third carbon. So it would look like this. And you have to make sure when you're drawing it, you put the right number of H's for the amount of bonds. To figure that out, you have to count the number of bonds between each carbon and its neighbors. And that will tell you the number of H's that you have to put on that carbon. So here, this carbon only got 1 H because you have 1 bond here and 2 bonds here. So you only have to put 1 H to make 4. So we've got our double bond there. And then we've got our 1, 2, 3, 4, 5, 6 for hex. And then the double bond makes -ene. Now, our next example, 2-methyl-1-butene, tells us that we have 4 carbons. And the 1 tells us the double bond starts on the first carbon and goes to the second carbon. So it would look something like this. And then you might be thinking this doesn't have any H's, but there's only 3 bonds. But that's because we have an attached group. So this tells us 2-methyl, that our group is on the second carbon, and it is a single carbon because of methyl. So it looks like that. So we have 1, 2, 3, 4 for but, and then our double bond is here, and our 2 is right here, and then the double bond gives us -ene. This example is a cycloalkane, which you just saw, and for those, your double bond always starts at carbon number 1, and then your attached groups, which are here, you want to number so that they have the lowest possible numbers. So in this case, we know we have 1, 2, 3, 4, 5 carbons. So we have that like this, 1, 2, 3, 4, 5. So we know it's going to be cyclopentene for sure, and we know it's -ene because of the double bond. So we look where our groups are. So if this is the first carbon, we have 1, 2, 3, and we have 2 methyl groups. So it would be 3, 3, dimethyl because we have 2 and they're both on the third carbon. And then we know our double bond starts on the first one, so that would be 1. And then it's a cycloalkane, so it would be cyclo, and then pent for 5, and -ene for alkenes. So we have -ene for the double bond, and 1 because it's on the first carbon, 2 3s because they're on the third carbon there, and our blue 5 for pent there. Our last example up here, we have 1, 2, 3, 4, 5 carbons. So we know it's going to be pent, -ene, and we have 2 fluorines on the second carbon, and our double bond is on the 1, 2, 3, third carbon. Nope, you want to start from the side that gives it the lowest number. So you actually would start from the right because that would make it on the second carbon. So that would make your fluorines on the 1, 2, 3, 4th carbon. So it would be 4, 4, because you have 2 of them, difluoro, 2 for the carbon, the double bond starting on the second carbon and going to the third, and then pentene for 5 and alkenes. So you have pent, ene, and then 4, 4, 2, difluoro. And that's how you do alkenes.